Section 1.8 is on the distance formula and midpoint formula. I'm going to learn how to utilize those formulas. We're going to start by looking at a basic triangle on a coordinate grid. All of today's lesson will be based on a coordinate grid. So there will be coordinates for each point. We know point A is at 1, 4. We know B is at 1, 1, and C is at 4, 1. If you want to look at the length from A to B, you can go ahead and count that. You just count spaces. 1, 2, 3. This length from A to B is 3 units. Same thing for B to C. You can go ahead and count those. The distance from B to C is 3 units. AC, however, cannot be found by counting spaces. The distance between the diagonal corners of a square is not the same as the distance between consecutive corners of a square. So although you can count for horizontal and vertical, you cannot count for diagonal. Therefore, there's a formula that allows you to find that length. Okay? Notice that if I wanted to, just for future reference, if you look at the distance between A and B and you look at the coordinates between A and B, notice that the difference between 1 and 1 is 0 and the difference between 4 and 1 is 3. That does relate to the distance here. Because it's a vertical line, the distance between the y values is the length of your segment. Same thing here, since B to C is horizontal, the difference between your x values gives you your length. For diagonals, it's related to that. We would use coordinates A and C. But notice the difference between 1 and 4 is 3, and the difference between 4 and 1 is 3. We would use those values to find the length. And what we are going to use is something called the distance formula. The distance formula is based on the Pythagorean theorem. It's based on the fact that a squared plus b squared equals c squared in a right triangle. So if you have a right triangle, we know that if this is A and this is B and this is C, that the length here squared plus the length here squared has to be equal to the length here squared. The distance formula is based on that. What it says is okay, if I wanted to find just C, I'd have to take the square root. I'd have to unsquare the C by taking the square root. Notice that these look very similar now. You have a big square root. You have something squared plus something squared. That's what you're doing. The only difference between the Pythagorean theorem and the distance formula is that I'm not just going to give you A and B. You're going to have to find your A value by subtracting the x coordinates of the points. And you're going to find your B value by subtracting the y coordinates of your point. So the first example that we're going to go through is I want you to find the distance between these 2 points. Okay, so the formula says the first thing you do is take your x values and subtract them. So here's an x value and here's an x value. So I'm going to take 9 minus 3 and I'm going to square it. Now my computer doesn't like to do square root signs, so I'm going to just draw them in here because that square root sign has to be done at the end. So I'm going to do 9 minus 3 and get 6, and then I will square that. Same thing here with my y values. Oops. I'm going to take the difference between my y values. I'm going to subtract my y values. 7, you can either do 7 minus negative 5 or negative 5 minus 7. It doesn't matter either way. In this case, I happen to get negative 12, but when I square it, when you square a negative, it's going to turn positive anyway. So you can see here I took 6 squared, and I'm going to take negative 12 squared, but that's going to turn to a positive. Anytime you take a negative value and square it, it's going to turn positive. So it doesn't matter whether you do 7 minus negative 5 or negative 5 minus 7. I'm just going to draw in my square roots because my computer doesn't like to draw them in. So 6 squared is 36. Negative 12 squared is 144. And then I'm going to add those together and get the square root of 180. That would be the exact answer. Or if I actually took the square root of it in my calculator, I would get 13.4. And it's distance, so it would just be single units, whatever the units are on the coordinate grid that you're looking at. A second one, just another example. This formula looks big and scary. It really doesn't take that long. Okay, so I'm just kind of giving you an abbreviated version here. I'm not writing everything out like I did in the first one. So the first thing you do is say, okay, what's the difference between my x values? The difference between -1 and +5 is 6. The difference between +3 and -4 is 7. Oops, these should have been squared. These are little squareds. So 6 squared is 36. 7 squared is 49. I'm going to add those together and get the square root of 85 as an exact answer, or 9.2 as a rounded answer. If I give you, or if you're given a segment on the coordinate grid and asked to find the distance, you do exactly the same thing. The only difference is that you have to find the coordinates first. So if you find the coordinates of this one is 1, 7, this one is 8, 0, then that's what you'd use to plug in there. So you'd say, okay, the difference between my x values, the difference between 1 and 8 is 7. The difference between 7 and 0 is 7. I'm going to square those. I'm going to add them together, and then I'm going to square root the whole thing. So you would do 49 plus 49 would give you 98. And then that would be your exact answer, or you could take the square root of 98 and get 9.9 units as your distance. The other formula we're going to learn is the midpoint formula. The midpoint formula is based on the idea that if you're given two segments, and you want to find the point that's directly in the middle of those, if you're given 2 points and you want to find the middle of those 2 points, it's just the average of those 2 points. So you have an x and y coordinate here, and you have an x and a y coordinate here. If you find the average of your x's by adding and dividing by 2, and find the average of your y's by adding and dividing by 2, that gives you the average point, or in this case, the midpoint is what we would call it. Okay, so notice we're going to add our x's in this case. We subtracted them in the distance formula, but in the midpoint formula we're going to add them. That's probably a very common mistake that kids make, is that they get confused whether they add or subtract. The midpoint, we add them and divide by 2, add them and divide by 2. So these are the same points. We're going to add 3 and 9 and divide by 2. But since it's the midpoint, since it's a point, our answer will be coordinates. So when you get down to your answer, make sure you write it as coordinates. That's different than the distance formula where you actually got a length. The midpoint would give you a point. Okay, so I'm going to add 3 and 9 and divide by 2, and then I'm going to add 7 and -5, and I'm going to divide by 2. That's how I'm going to get my midpoint. 3 plus 9 is 12. 12 divided by 2 is 6. I'm going to add 7 and -5, and I'm going to get 2, and I'm going to divide by 2 and get 1. So my midpoint of these 2 points would be 6, 1. 6, 1 is the average of those coordinates. A second example, just so you have 2, -1 plus 5 would be 4 divided by 2, and then 4 plus -2 would be 2 divided by 2 would be 1. So here's your original, sticking them into the formula, and then this is your end result. Your midpoint is 2, 1. That is the average point between these two coordinates. Oh, one last thing. It's okay to get decimals here. If you get decimals, it's okay. I just happened to pick 2 examples that give you whole numbers, but decimals are okay there. Please check your pacing guide for the suggested problems for 1.8.